In this quick tutorial, we are going to discuss the concept of percent yield as well as how to calculate a percent yield. So before we get into the actual calculation of a percent yield, let's define a few terms. So the first term I want to define is called your theoretical yield. Your theoretical yield is your calculated amount of product that you should get when you use like a stoichiometry problem. So I have a chemical reaction and I make a calculation as to how much product I'm going to produce. That's my theoretical yield. That's what I should get. My actual yield is when I go back in the lab and I then perform that chemical reaction and I get a product and then I measure the amount of that product. That's my actual yield. That's what I really got. That's my experimental yield. So what's the difference between a theoretical yield and an actual yield? Well, the theoretical yield is your calculated, what you should get, whereas your actual yield is what you really get. So I like to think of it like, you follow a cake or a cupcake recipe and it tells you that you're going to be able to make a dozen cupcakes. Yet somehow you will, you serve it out just like they say and you end up with only like 11 cupcakes instead of 12. So your actual yield was 11 cupcakes, whereas your theoretical, what you should have gotten, was 12. So what's a percent yield? Well, a percent yield is where you take your actual amount and you express it as a percentage. And you need to know this equation, so I'd write this down. The percent yield is going to be what you actually got in a lab divided by what you should have gotten from your calculation, and then of course multiplied by 100 to express it as a percentage. So you should know that it's extremely rare to get 100% yield. There are always sources of either systematic or random error when you're doing a lab activity that would result in your actual yield being different than your theoretical yield. But you want to get as close to 100% as possible, of course, but it's very, very rare that you actually get 100% yield in an actual lab situation. All right, so let's do a quick little percent yield problem here. So the question that I'm asking is the percent yield of carbon dioxide if 60 grams of calcium carbonate is heated to produce 19.7 grams of carbon dioxide. And then I've given you an equation, which you want to double check that it's balanced, and of course it is. So first of all, let's kind of look at what we're given here. So we're given this, that we know that we're starting with 60 grams of calcium carbonate, and we go in a lab, we heat it, and we produce this much carbon dioxide. So this is going to be your actual yield of carbon dioxide. So you got to read the question and be able to identify that that's what you're really getting. And of course, to calculate percent yield, we've already got the actual yield because it was given. So now we need to calculate the theoretical yield. So that's where the 60 grams of calcium carbonate comes in. So we'll do a little quick stoichiometry problem to calculate our theoretical yield. So to do that, we're going to need to get our grams of calcium carbonate into moles so that we can compare it to the chemical equation. And of course, we're going to do that using its molar mass. So that's going to get us into moles of calcium carbonate. And then we're going to use the mole ratio from our equation, which happens to be 1:1 mole of calcium carbonate to carbon dioxide to get us to moles of carbon dioxide. And then, of course, we want grams, so we can calculate our percent yield. And so a mole of carbon dioxide has a molar mass of about 44.009 grams. So that'll get us to grams of carbon dioxide, which happens to be 26.4 grams of CO2 in theory, right? So that's our theoretical yield. We got that from stoichiometry, from doing a calculation. All right, so now we can calculate our percent yield. So to calculate percent yield, like it says right here, we are going to take our actual yield from the question. It tells us that we actually get 19.7 grams of CO2. We're going to divide that by our theoretical yield, which is 26.4 grams of CO2, and we're going to multiply by 100. And we get, if I'm incorrect, I'm sorry, but I don't think that I am, we get a 74.6% yield of CO2. That means that we only recovered 74.6% of what we should have gotten. So that's how you calculate percent yield.